Module 2, Networks and Decision Mathematics. Question 1. The diagram below shows a network of roads from Leah's home to the airport. Her home and the airport are labeled as vertices on the network. The vertices P, Q, R, and S represent road intersections. The number on each edge represents the distance in kilometers along that section of road. Part A. What is the degree of vertex P? Since there are 3 roads going into P or from P out, the degree is 3. Part B. What is the shortest distance in kilometers between Leah's home and the airport? By inspection, the shortest distance is from home to P to R to S and to the airport. That is 15 plus 20 plus 12 plus 8 equals 55 kilometers. Part C. What is the mathematical name of the edge that forms the drop-off zone? That is a loop. Part D. An incomplete adjacency matrix for the network on page 20 is shown below. Write the missing 4 elements in the spaces provided in the matrix. Column 1, row 1, there is a 0. In row 1, column 2, there is a 1 because there is only one road between home and P, and the same between P and home, so there is a 1 in row 2, column 1. There is a 0 in row 3, column 1, because there are no direct roads between home and Q. Question 2. Leah must book a last-minute flight from Melbourne to London. There are no direct flights. However, TravelSafe Airlines has flights available from Melbourne to London via Brisbane, Hong Kong, Abu Dhabi, Amsterdam, and LA. The network below shows the maximum number of seats still available on these flights. A cut, labeled Cut 1, is also shown on the network. Part A. How many different flight routes are available from Melbourne to London? There is one from Melbourne to Brisbane to LA to London, a second one from Melbourne to Hong Kong to London, a third one from Melbourne to Hong Kong to Amsterdam to London, a fourth one from Melbourne to Amsterdam to London, a fifth one from Melbourne to Abu Dhabi to Amsterdam to London, and a sixth one from Melbourne to Abu Dhabi to London. So there are 6 different flight routes. When considering the possible flow through this network, different cuts can be made. Part B. What is the capacity of cut 1? To calculate the capacity of a cut, we add up the values of the edges that go into the cut from left to right. So the capacity of cut 1 equals 12 plus 8 plus 14 plus 20 equals 54. Part C. What is the maximum number of seats still available to travel from Melbourne to London on this day? For this, we are going to look for the minimum cut. To calculate the capacity of the minimum cut, we are going to add up the values of the edges that go into the cut from left to right. Therefore, the maximum number of seats equals 5 plus 8 plus 14 plus 20 equals 47. Part D. TravelSafe Airlines can add 8 extra seats to one of its flights in order to allow 8 more passengers to travel from Melbourne to London on this day. Name 2 cities between which these extra seats could now be available. First, we are going to look at the flight from Melbourne to Brisbane, Brisbane to LA, and LA to London. If we add 8 extra seats to the flight from Melbourne to Brisbane, this is not going to add 8 more passengers on the whole flight because of the restriction of 12 on the flight from LA to London. Also, if we add 8 extra seats to the flight from Brisbane to LA or LA to London, that is not going to allow 8 more passengers because there is a restriction of 5 seats from Melbourne to Brisbane. Now, let's look at the flight from Melbourne to Hong Kong and Hong Kong to London. Adding 8 extra seats on the first flight, it is not going to allow 8 more passengers because of the restriction of 8 passengers on the flight from Hong Kong to London. However, if we add 8 extra seats on the flight from Hong Kong to London, that is going to allow 8 more passengers to travel from Melbourne to Hong Kong to London. So the answer to this question is going to be between Hong Kong and London. Question 3. TravelSafe Airlines is planning to renovate a passenger terminal. This project will involve 12 activities, A to L. The directed network below shows these activities and their completion times in weeks. The completion time for activity J is labeled X. The minimum completion time for this project is 20 weeks. Part A. What is the value of X? So we know that the minimum completion time for this project is 20 weeks. We are going to start by calculating the early start time for all these activities. The early start time for activity J is 12. To calculate the value of X, we are going to start from the finish. We know that this is 20, so we have 20 minus 3 equals 17, so 17 is the earliest start time for activity L. Since the completion of activity I takes 15 weeks, then the completion of activity K should be 17 weeks. Therefore, we have 17 minus 1 equals 16. So the earliest start time for activity K is 16. The completion time for activity F is 15 weeks, and for activity G is 14 weeks. Therefore, 12 plus X should be equal to 16, which means that X equals 4 weeks. Part B. Complete the following sentence by filling in the boxes provided. This question is asking for the activity with the longest float time and the value of this float time. For this, we now need to calculate the latest start time for all the activities. We can now see that the activity that has the longest float time is activity B with 5 weeks. Part C. How many activities could have their completion time increased by 2 weeks without altering the minimum completion time? These activities are the ones that have a float time of at least 2 weeks. And these activities are activity B with a float time of 5 weeks, activity E with a float time of 2 weeks, activity I with a float time of 2 weeks, and activity G with a float time of 2 weeks. So there are 4 activities. TravelSafe Airlines has employed more staff to work on the renovation project. This has ensured that no activity on the network above will have an increase in completion time. However, the completion times of activities G and H are each reduced by 2 weeks. How will this affect the overall completion time of the project? Let's start by reducing activity G by 2 weeks, so that becomes 6. 6 plus 6 equals 12. And now we are going to reduce activity H by 2 weeks. So we have 6 plus 4 equals 10. So 10 becomes the earliest start time for activity J. And now we have 10 plus 4 equals 14. So the earliest start time for activity K is going to be 15. 15 plus 1 equals 16 for activity K. From activity I, we know that 8 plus 7 equals 15. So we choose 16 as the earliest start time for activity L. 16 plus 3 equals 19, which means the finish time is going to be 19. So the completion time for the project is going to be reduced by 1 week.